Now we will look at how to make a sketch of cosine curve. So first, we want to consider the variable t versus cosine t. And t as a real number here indicated by this central angle. So for this t, we have a real value. If we use a unit circle, and we know that the arc intercepted by this angle has also length t. So the length of the arc has the same value as the angle measure. So the t are the same. So that's for the unit circle. But we want to focus on this t and the cosine value for different t. So we want to study the behavior of cosine function. Usually we represent a function using y, for example, cosine of x. The reason I reserve x and y for another purpose, because remember xy can also be used as xy coordinates of a point, right? So I want to use xy for that purpose. So do not confuse yourself. So in this video, and xy is not related to the function value, but just xy coordinates of a point of the terminal side. And this point is also intersection of the terminal side of t with unit circle. That means it is not only on the terminal side, it is also on the unit circle. So yeah, that's the meaning of xy. So coordinate of the point. And now, how do I represent my function? I'm going to use t for the independent variable. So cosine t, the function value, the function, right? Cosine t is the dependent variable. So let's call it f. It's the function we're focused on. It is the cosine function. Yeah. So that means I want to study when t changes, what happens to the curve, the cosine t, right? The function behavior. So let's think just to pick two different values in this range. So let's pick two different values. That means this t, right, from 0 to half of pi. So we see already one, that is the 1t, and then I pick another one here. This is the t for this t, and there is a point P, and x coordinate of the point P will be cosine of the t. The y coordinate will be sine of t. But right now we focus on cosine. So x coordinate. So let's look at this point P. Its x coordinate is here in pink. And with the other P here, the t value is larger, right? The x coordinate, which is cosine value, it is actually smaller. You see the x smaller. So we notice the larger the t, the smaller the cosine t in this range. Yeah, so we notice when t increases, right? The larger t will be, the larger the t, the smaller the cosine t. So that's why we have a decreased value in the cosine t. And more precisely, how it decreases. Imagine if our t is 0, if t is at 0, so that means you have this, that's the terminal side of t when t is 0. So the x coordinate is 1, which is cosine t is 1. So cosine t is 1 when t is 0. And when t increases to pi over 2, what happens? When t increases to pi over 2, so if this is our t, and for this, immediately we see x coordinate will be 0, right? So that means cosine t is 0 for this point P, because cosine t is the x coordinate of the point. And we can see the x coordinate of this point is 0. So we notice at pi over 2, when t is pi over 2, the cosine t becomes 0. So we see it decreases from 1 to 0 when t increases from 0 to half of pi. So similarly, we can think for the t continued, if it increases from half of pi to pi. Let's look at this value t. So let's just look at the x coordinate of this point. So the x coordinate of this point, let's use a pink. That's the x coordinate. It's negative. So when you have a larger t, what happens? When you have a larger t, you can do another one, then it's going to be more negative, right? So you can always try to think of another t. Let's put in yellow. And then what's the x coordinate? This is the point P intersection. And then go to the x coordinate. It's going to be this. It's going to be more negative. So yes, so that shows the t is increased in this range. The larger the t, the more negative the cosine t. So the cosine t decreases. It's negative until the smallest value will be -1 when the point is here, right? When the point is here, that corresponds to the pi. Yeah. So when your t is pi, then you get a -1. So similar analysis can review the behavior of cosine when t is in this range. So suppose t is bigger than pi but less than 3 pi over 2. So suppose t is here, which is in the third quadrant. And this is the t. And what is the cosine t? Cosine t, according to our understanding, cosine t will be this x coordinate, right? So then if t is increased For example, here is another t. Let's show this t is increased to this point. Then what will be the cosine t? Cosine t will be the x coordinate of this point P. So x coordinate is here. So we notice it will be less negative, right? Still negative, but for this t, which is increasing, this angle is increasing. So we see less negative. So that means our cosine t is increasing. This cosine t is increasing, although negative, from, but it's becoming less and less negative until it is zero. That is, when your point P is here at this, that corresponds to 3 pi over 2. If we draw indicate the t is here, when the t is 3 pi over 2, the x coordinate of this point will be 0. That is cosine t. Cosine t is 0. So from negative to 0, and the larger the t in this range, and the larger cosine t. So we see the increase. The increase indicated by the x coordinate. As you can see, the pink portion, right, becoming the red, and becoming later the 0. So then on the last quadrant, so we still assume our t is just in this range. So, but that means it's in the fourth quadrant. So if we increase and the t value is more than 3 pi over 2, or can be equal to, but let's assume it's in this. So that's our t right now. And what is cosine t? Then just for this point, that's the x coordinate of the point. So we can show that it's positive, right? Or non-negative. So because at this location, P is 0. We remember that. So when T is 3 pi over 2, then here cosine T will be 0. Then when T in this range and increase to another value, let's assume I draw another T here. This is a bigger T because it's going to go all the way here. So yeah. So that point P will have a x coordinate, which is the cosine T in red, you see, more positive. So that shows the cosine T increases, right? In this range, when T increases from 3 pi over 2 to 2 pi, the cosine of T increases from 0 to 1, because at the very end, when the T is 2 pi, when T is 2 pi, see, that's the point P, its x coordinate will be 1. Yeah. So increase, it's a non-negative, right? From 0 increase and to 1. So after our analysis, then we can do a sketch, because we can show a curve when T is in the first quarter of this whole overall interval, because the interval will be for T from 0 to 2 pi. But we will construct T from 0 to half of pi, and from half of pi to pi, and from pi to 3 pi over 2, and from 3 pi over 2 to 2 pi. So then we will see on each portion of the entire interval from 0 to 2 pi, then we will get a picture. That means first it decreases, and then it continues to decrease, and start to increase, and continue to increase. So that's the behavior. And to see the using data points, we can draw a table just to get some concrete values of cosine t or different t values. So because our interest is to do a sketch of cosine curve. So this t, we just simply choose a number of special values, because on those special values of t, we can give exact cosine value. So at each t. So here, pi over 6, we know the cosine value is this. Pi over 3, we know the cosine value, the exact value of cosine at each t. And you see they are all special, right? Pi over 6, pi over 3, pi over 2 of pi, right? This 2 pi over 3, and its reference angle will be also those. So very easy to get the exact function values. The table structure is done this way. That is, we just evenly increase. We increase the t value by pi over 6. So here, 0, right? Well, increase the t value. I get pi over 6. And next, the t value will be increased by another pi over 6. You see, pi over 6, if I increase it by another pi over 6, that's 2 pi over 6, which is pi over 3. So I keep increasing the t value. When pi over 3, I add another pi over 6, I will get pi over 2. So this way, I get a list of different t values, and they differ by each successive t value, right? So the difference is just the pi over 6. So for this, that means the t values are evenly spaced. So they just go to next t value until I arrive at 2 pi. So when t is 2 pi, we know that we finished a complete cycle. Right? Imagine that center angle I just showed. So then at 2 pi, you have completed a complete cycle. So then cosine t at each one of the special angles can be calculated, and we have such a table. So ordered pair will allow you to do a scatter plot. So let's just look at the curve. So you see, this is another ordered pair, and then another ordered pair. You will, each ordered pair, you just show, yeah, at each t, the function value. Then you can see at least these many points of the function. But we know the cosine t is defined for any t, right? With this picture, we can see for any t from 0 to 2 pi, and any number between 0 and 2 pi, including 0 to 2 pi, for any t in this interval, and cosine t is defined. Why do I say that? Because for n in t, this cosine t must be defined because there is always a point that has an x coordinate, right? You can always discover the x coordinate of such the point corresponding to t. Yes, so the cosine t is defined for all t in this interval. But certainly it is also defined for n and t bigger than 2 pi because the reason is, suppose you have a t in this interval, it is defined, then 2 pi plus t is just another angle that shares the same terminal side. So we know that the cosine 2 pi plus t will be the same as cosine t. So this is to say that 2 pi is actually a period of cosine function. So now we are ready to take a look at the basic cosine curve. So the basic cosine curve, yeah, once you remember decrease first. So let's look at the plot of those points. Then we see from 0 to 2 pi, from 0 to 2 pi, right? In the first range of this interval, you see from 0 to half of pi, we know cosine t is decreasing from 1 to 0. Yeah, it's decreasing. And from half of pi to pi, on the next interval, the cosine t continue to decrease. Yeah, it's becoming negative and more negative until it is -1 here. So it's -1 at pi. And then if we increase t, that means if we look at the t in this range from pi to 3 pi over 2, if t is in the next range here, then the cosine t will increase. The cosine t will increase from, but still negative. Yeah, but it's less and less negative until 0. And if your t is in the fourth quadrant, remember in the actually, let's use the real number to indicate that one. So when t is between 3 pi over 2 and 2 pi, then the cosine t is positive. And positive, and it's more and more positive. That's from 0 to positive until +1. Yeah. So you see, from 1 decreasing to -1, then from -1 increase to +1. So that's the overall, the behavior on the entire interval from 0 to 2 pi. So we have finished one complete cycle, that is one period of the cosine t, cosine function. And certainly in this picture, we show that, so the horizontal axis is t. The vertical axis will be the function f, which is cosine t. Yeah, cosine value for different t's. So you see the picture, although you see only those special points, only to get a sketch of the cosine, but the cosine curve is defined for every point in this interval. So that's why if we connect those points with the curve, and then we get a pretty good sketch of the cosine curve. So, and we know the cosine is defined for all real numbers in this interval from 0 to 2 pi. But also, it is defined for all real numbers because this behavior will continue beyond this interval. So every 2 pi is just one complete cycle, and then the behavior will continue, will repeat itself. So we can draw the cosine curve on the larger intervals. So let's take a look at two periods of the cosine curve. Oh, this is still one period. The reason I want to show one period is instead of doing so many points, let's show what are the most important points. You see only 5 points, right? 5 points. We can say 5 points sketch. That means compared to the previous one period, we take away those points. We suppose we know the feature, then in the future, if you do a sketch of a cosine curve, we can omit those points just to make it simple. Let's drop those points because we only want to show the most important ones. Then which are the most important ones? The maximum, right? This is quite important. The minimum, this is also important. Another one, the highest point. So those are very important. And also we can show the x-intercepts. That's where the function value is 0. So then we have only 5 points. So if we can show the 5 points and based on our knowledge of cosine curve, and we can already sketch the cosine curve. So let's use 5-point approach to just show the minimum, maximum, and x-intercepts. So here is the 5-point. Highlighting the curve feature, right? From largest value to decreasing to 0, and then continue to decrease, -1. And then from there, increasing to 0, and you continue to increase to +1. So that's one complete cycle over the interval from 0 to 2 pi. And to look at the 5 points in a table, it's very easy. Just you see from the 0 is 1, right? That's the ordered pair. At half of pi, it is 0. That's another ordered pair. So let's make it slightly smaller. Yeah. So, okay, so this we can see the 5 points. Just 0 at 0, function value is 1. So that's a point. At half of pi, function value is 0. That's the one of the x-intercept. And when the input value is pi, I mean the t value, the function value will be -1. Right? This is -1 at pi. So that's another point. So we can see the 5 points, each right dot corresponding to an ordered pair. Yeah, I have 5 ordered pairs, and here those are the plots, yeah, of the 5 ordered pairs. Okay, so you have seen this one period of cosine. Now, what if I want to see the cosine function on its domain? Because the cosine function is defined for any real number t. So we can extend the picture to a larger interval. So here, suppose we have, let me frame one period that we just got, right, from 0 to 2 pi, and that is from 0 to 2 pi. And if we want to produce picture that is from 2 pi to 4 pi, then we can produce the same curve on another interval because the behavior will repeat. So let's show from 2 pi to 4 pi. Yeah, so, and then the picture will be, so once we get the largest point, then it will first from the decreasing, right, continue to decrease to -1, and then increasing to 0 and continue to increase to +1. Yeah, so it's just another period. So we can show the actually we can, yeah, so see 2 periods, and certainly you can see 3 periods if you want. So that means it can, the graph can be extended either way, to the left or to the right. So here is the general feature of the cosine curve. So if we look at from -2 pi to 0, that's another interval with the length. So then that's another period, right? So we see 2 periods from -2 pi to +2 pi. Yeah. So you can see as many periods as you want. Just extend the this behavior, the periodic behavior, from one period to many periods. So you can get a whole picture of the cosine function. Therefore, the domain of cosine function is on all real numbers. And the range of cosine function, that means cosine t is the function. The t means, domain means all possible values of t will be all real numbers. It's all real numbers. And the range means possible function values, right? This is the function. All the cosine values can only be between all values between -1 and 1, including those -1 and 1. So you can see that the largest value will be +1, the smallest value will be -1, and any value between. Yeah. So that's the basic cosine curve.